Good morning, sir.
Good morning.
Good morning, sir.
Good morning.
Good morning.
Good morning, sir.
Good morning.
Good morning, sir.
Good morning.
Good morning, sir.
Good morning.
So what topic do we have this week, sir?
For this week, this is transport in plant also.
Yes, sir.
Again, it is same, but it will be complete, complete part. Transport in plant, complete chapter.
Sir, once can you show botany extra class notes, sir? I will take screenshot.
Yes, sir.
Okay. Do you have any doubt in that paper, test paper?
Yes, sir.
Okay. Just
So from water movement of a plant, those topics are there, sir. Water movement of a plant.
water movement of yes, water movement plant means the chapter. You are asking about the test syllabus, no? Next.
Yes, sir.
test
The root pressure, transpiration, those topics are there, sir.
overall complete. All topics are included in transport in plant. So
Yes, sir.
this will be complete transport in plant in next syllabus.
Yes, sir. Yes.
Next test, yes. So we'll complete in these 3 days, no issue. Just a minute. I'm showing you this test paper first of all.
Good morning, sir.
Good morning. If you have any doubt, otherwise we'll start the class. Hello.
Sir,
If you have doubt, then we can discuss. Otherwise, we'll go ahead. If anybody has, just a minute. 13th. Okay. Yes. This is botany portion only, huh? Fine. Question number 91, 92, 93. I'm not discussing each and every question. Okay. If you have any doubt, then we can discuss. Otherwise, we'll go ahead. 91.
Sir, I
92.
cannot see your screen, sir.
Huh? Just
I cannot see your screen, sir.
okay. Sorry. I
yes,
forgot to share the screen. Just a minute. Yes. Now is it okay?
Yes, sir. It's okay.
Yes, sir.
Fine. Question number 91, 92, 93, 94, 95, 96, 97.
96.
Yes, 96.
92, can you tell, sir?
92. Okay. The porine are proteins that form large pores in the outer membrane of the. Okay. So generally these are present in the membrane of prokaryotes, especially, and in eukaryote generally they are present in the plastid and mitochondria because these are also prokaryotic-like structure inside the eukaryotic cell. So mostly these porins are generally formed in these structures. So I think option is ER, plastid, mitochondria, B option. Plastid, Golgi body, all bacteria. No, not all bacteria, some bacteria.
So it should be B, no?
So B option should be there. Okay. Question number 93, 94, 95. Someone asked about 96, no?
Yes, sir.
96. Water potential, osmotic potential. Okay. Water potential is 0. It is 0.
0 and 0.
And osmotic
sir.
potential, it is also 0 because it is pure water, no? Osmotic pressure means what? The pressure produced by solute. But this is pure water. It means there is no solute. So it is 0.
Okay, sir.
So B, 0, 0. Okay, 97, 98, 99, 100.
Sir, 99, sir.
100. Sir, 100.
100,
Okay.
sir.
99 and 100. Okay, okay. Net movement of water is from.
Option C, sir. DPD gradient plays on role.
DPD gradient plays a role.
Low DPT to
Option
high
A, sir.
DPT.
But
Option A,
option A is most correct. Na? This is clear-cut statement. Net movement of water is from. Water starts movement from this to this. So from low DPD, low suction pressure to high suction
High
pressure.
section figure.
So it will be more correct. No? You have to choose more correct answer. Okay. Generally, you can cancel two. You can remove two options. But in general, in the objectives, two options will be almost same. Okay, similar. So you
Sir,
have to choose
actually-
most correct.
Sir, actually in option C, I think it's not on. It's no, I think so. Any printing mistake happened or something.
In role, no? Yes, this is printing mistake. Actually, option A is most correct.
So it is the only
Concentration
correct
gradient. Actually, DPD gradient, it is okay. DPD gradient is yes possible. Gradient means difference. So the difference between two solutions, difference of DPD in two solutions, it also play a role. But which role? High to low, low to high. So water moves from low to high. That gradient is possible. Okay. So exact answer is low to high DPD.
Okay, sir.
Yes. 100. Purple cabbage leaf do not lose their color in cold water. Okay, okay. Plasma membrane get killed and boiled. This is the answer, I think. Plasma membrane get killed.
Hot
Plasma
water can
membrane
enter the
actually-
cells readily.
Huh?
Sir, even D can be right.
Option B, sir.
Option
No,
A
no.
only. Sir.
Option A only, sir.
He is not saying that which enters the cell. He is saying purple color cabbage leaves do not lose their color, and color is actually because of anthocyanin pigment. A pigment is there which is stored in the vacuoles. Okay, so this plasma membrane is killed by heating or by in the boiling water. Okay, so because of this water moves out, this color moves out. That's it. So there is no question of which is entering or which is exiting. The purple color, it is free now in the cell or in the water because there is no cell membrane. So A option only. Okay, 101, 2, 3, 4, 5,
Sir, 1 or 2.
102. Okay, this is the diagram. I think it is from NCRT direct. NCRT or sheet, Reso sheet.
NCRT, sir.
Yes, it is given in a Reso sheet also. Okay, simple. There are two different solutions. One is dilute solution, another is hypertonic solution or concentrated solution separated by a selective permeable membrane. That's it. Fine. Abhi dekho, solid molecules, they are less in A and more in B. So water potential. The question is water potential, solid potential, water potential. Okay. So only two points: solid potential, water potential. Fine. Solid potential. First of all, water potential. Okay. So in water potential, you can see the dilute solution. It means less solid material. It means water potential should be more. Okay. Means it is near to zero, not exactly zero, but it should be near to zero. So water potential is high in A. Okay, so option B and C shows water potential. Water potential of chamber A is lower. That is wrong. Water potential of chamber A and B is same. That is also wrong. So these two are cancelled. B and D. These are not options. Now A and C. See this. The solid potential of chamber A is lower. The solid potential of chamber B is lower. Okay, so you have to decide where the
Yes, sir.
solid potential is lower. Fine. So simple. Solid potential in B, in B ka case means the B solution, it has more solid. It means solid potential is more in B. So it is lower in A.
Sir, solid
clear?
potential is lower in B, no, sir, because the solutes are more in B.
Solid potential of chamber B. Hello. What's your
So the
confusion?
answer should be C, no?
The solid potential of chamber A is lower than B, and C option is solid potential of chamber B is lower than A. So which is true? The question is on the basis of below diagram, which statement is true? Okay. So in B, more solid is available, more concentrated solution. It means solid potential is more in
Yes.
B. So obviously the solid potential of A is lower. So which statement is correct? Solid potential of chamber A is lower than B. A option, not B. C. B ka solid potential is higher. Okay, because more solid is there. Clear?
That means more concentration means more negative value, no, sir.
हाँ, negative value more होगा, but means what? Negative value more means solid potential is more strong. Okay, it is more strong.
Actually, I've read that more the solute is, less the solute potential is.
Hmm?
More the solute
No, no,
is,
no.
less-
I said that time it shows psi s. It shows the concentration of solute in the solution. Okay, and it is negative, more negative. If suppose you take pure water. Okay, so this water potential is 0. That is maximum. If you are dissolving some solute material, it means solute potential increases. Solute ka pressure increases here. Okay, and because of this, it becomes negative. So it is not negative or positive. So you can say it is higher or lower. If it is negative, negative means it is more strong solution. No, it is more strong. More negative means more powerful. More solid potential is developed. Means suppose you are comparing two concentrated solution. Okay, one is less concentrated, another is higher concentrated. One is sugar solution, dilute sugar solution, another is honey, suppose. So where solid material is more? In honey. So that is more solid potential and it becomes more negative. Is it clear?
Okay, sir.
So A option is most correct. Okay. 103, 104, 105, 6, 7.
Sir, 103.
Sir,
106.
sir, 106.
106.
Just a minute. 103 now. Hello.
Sir, 106,
Yes, sir,
sir.
103.
No, before
103.
106,
Yes, sir.
106, 103. Okay, apoplast, which involves in apoplast. Apoplast means dead material, means cell wall, or maybe the gap between the cell, means here no living material. No. So 103, plasmodesmata and cell wall, intercellular space and cytoplasm. Okay, cytoplasm, cell wall and intercellular space. Apoplast, non-living. So cell wall and intercellular space. C option. See, plasmodesmata means what? This is the gap between two cell or two cells. Now, so two adjacent cell. It means here the cytoplasm is present. Cytoplasm is interconnected. So this is living material. Intercellular space and cytoplasm in B option. Cytoplasm is living material. Similarly, in D option, cytoplasm is given. It means it is living material. Fine. So only option C is there, which is the answer. Apoplast. Apoplast, cell wall, intercellular space. Now 106. Cell with fully elastic wall is placed in hypertonic solution. What will not happen? Okay. Hypertonic solution, it means what? It means water is moving out. Okay. So definitely size and shape changes. Change in size and shape. Yes. Okay. The whole cell will shrink. Slightly shrinkage occurs. Correct. Cytoplasm shrinks from the cell wall and undergoes plasmolysis. Decrease in cell size. It also occurs. Decrease in cell size because of shrinkage, because of change in shape. Okay. I think option C should be correct.
Yes,
Any
sir, C is the
reason?
correct answer.
Why? He's saying cytoplasm shrinks from the cell wall, not protoplasm. Okay, the plasmolysis ka definition is protoplasm is constricted. It becomes concentrated. Okay, total protoplasm. What is protoplasm? Protoplasm means it includes nucleus also. Okay, not only cytoplasm. These are two different components, na? Cytoplasm
difference?
and nucleus. Huh?
So what is difference between protoplasm and cytoplasm?
That is I'm explaining now. Protoplasm means what? Cytoplasm plus nucleus. Okay. Here only cytoplasm shrinks. It means you are avoiding that nucleus. It means it is not included nucleus. So it says not only cytoplasm but protoplasm. Overall protoplasm is included in this plasmolysis process. So that is why this answer is correct. Actually, all four options means they seem like all are correct. Okay, but here cytoplasm is not correct. Cytoplasm means actually this is the only material which having non-living materials, non-living substances plus cell organelles. Okay, so you are excluding nucleus. So overall cell it shrinks. So I think C option is correct. Is it clear?
Yes, sir.
Okay. 107, 108, 9,
108.
108. Osmotic pressure of a solution is more than pure solvent. More than pure solvent. हाँ यही होना चाहिए. More than pure solvent. Yes. Less than pure solvent. It is wrong. Variable depending upon concentration equal to that of pure solvent.
It can be C option.
Variable depending upon concentration. If concentration is high, OP is high. If concentration is less, but A option is also correct, no? Pure solvent they have zero osmotic pressure.
A, sir.
So more than that of pure solvent. I think A is correct. Variable
So then
depending
C also
upon
correct.
Yes, so C also can
equal
be
to that
correct,
of
sir.
pure solvent.
You also know, sir.
It is variable depending on concentration. Let me check this one. 108 MB. A is
C
correct, na?
is-
C is
A is
also
given, sir.
A is given, sir.
A is given. A is correct, but C it says variable depending upon concentration. Okay, let me check this one. If it is correct, then it will be a correction. Okay, means both options are correct, A and C. So first of all, I have to check this one. 108. Fine. But most correct, I think it is A. Okay. 109, 1010, 11, 12, 13, 14, 15,
So 1
So 13.
114, 113. Okay. What is 113? A B contiguous. A has OPT 10.
So what is
And,
contiguous?
TP connected. They are connected by some tubes. Okay. It is just experiment. So OP10, DP7. So DPD is equal to 3. Okay, DPD is also given. Good. Another DPD is 5. So it means from where to, okay, no movement of water, equilibrium between two, movement of water from A to B, movement of water from B to A. I think it is DPD is higher in the second case, na B. It means suction pressure is high. So water moves from A to B. A to B. I'm just coming here. Just in 1 minute.
మీ నాన్న ఆ బాబా గడి పని పడదాం.
Okay. Can you hear me?
Yes, sir.
Yes, sir, we can hear you, sir.
Okay, so 113 का answer should be A to B. Okay, A has less water diffusion pressure deficit, less power to absorb water. So A to B. 114, 15, 16, 114. Okay. Over a small distance, substance move by small distance. Okay, small distance means this is diffusion.
Diffusion.
And by cytoplasmic streaming supplemented by
Active transport.
cytoplasmic
Sir, it can be
Osmosis and
applied.
active transport.
streaming supplemented by active transport. So answer facilitated active diffusion osmosis, active transport osmosis. Diffusion active, D option. It is correct. Small distance per moment, that is called diffusion. If it is long distance, it is called translocation, like route to leaf. I explained this one. So this is called diffusion and cytoplasmic streaming supplemented by active transport. It uses energy. Okay.
So what's the meaning of cytoplasmic streaming, sir?
Streaming, cytoplasm moves, means inside the cell cytoplasm moves continuously. Okay. So during this ATP is used sometimes. That is active transport. Okay, 115, 116.
So 116.
116.
So the
116.
correct
For a
answer in
solution at
114 was
for a solution, 1 1
correct answer in 114.
114 is D na, diffusion and active transport. This is fill in the blanks like question.
But sir, in answer key
First-
it's given B.
Answer key. No, I think it should be D only. It is not osmosis. Cytoplasm
It's
streaming
given
is
D.
inside the cell.
D only is given.
Yes, sir,
Given D
it's-
only, sir.
D, I think. Yes, D.
Yes, sir, it's given D.
See that answer key again. It is D only. Okay, 115, 116 na?
Yes, sir.
Yes, sir,
116.
116.
Okay, 116 में water potential is more than W, solution atmospheric pressure. For a solution at atmospheric pressure,
Yes.
okay, means you are not increasing or decreasing, this is constant. Okay, means one given atmospheric pressure. Atmospheric pressure is given. I think both are equal. Water
your voice
potential
is
and
breaking,
solid
sir.
potential. Water
Sir,
potential.
your voice is clear, sir.
Oh, sir, it's clear.
Okay. I think it is W and S. Solid potential and water potential are equal
Yes, sir.
at
Sir, I
atmospheric
think
pressure.
A is the correct answer, sir.
Yes, sir. A is the correct option, sir.
Yes, sir.
I
Yes,
could-
sir.
More than solid potential.
Yes, sir. Because
Yes,
water
sir.
potential equals to solute potential plus pressure potential. No, sir. That's why.
At atmospheric pressure,
So
the
we have
pressure
to add to
potential
get
is
water
zero.
potential. No, sir.
Yes,
Okay, it means just
Means
yeah,
atmospheric
correct.
means water potential. If we subtract solute potential from water potential, we should get atmospheric pressure. No, sir. That's why they are not equal.
Mhm. Okay, let me check this. 116. 116. So answer is given
C.
A or C?
C is given, sir.
Huh?
C.
C, sir.
Third. Okay. Answer is given C. It should be A. Just a minute. Okay. So 108 and 116.
Sir, if any mistakes in the answer key, then will we get more marks?
Yes, yes. I will
That's
send
good.
this one after class.
Okay. Should we claim or you will see, sir? Or
No,
they
no,
will
no.
automatically?
The office will correct this one. We have to send all these corrections after the class to the office. Okay. So they will look into the matter.
Yes, sir.
Okay. 116, then 117.
117. Yes, sir.
117.
Okay. 117 again. Even during wilting. So as you know, wilting means what? Wilting means loss of water. Okay. 117. So correct sequence. What is the correct sequence?
Options.
Water is coming out of the cell. No, that is exosmosis. Okay. If exosmosis occurs, it means what? It means it starts plasmolysis. Fine.
Exosmosis, plasmolysis,
Option B.
temporary wilting.
Option B, sir.
C, sir. It's
Option C.
Option B.
Option
I
B.
have
In option C, it is given endoosmosis. It is not endoosmosis. No? It is not
Option B,
endoosmosis.
sir.
Option B is there.
Option B, sir.
Exosmosis. Yes, option B. And plasmolysis. Temporary wilting. What is temporary wilting? Actually, generally, wilting
class.
occurs in the plant. during
117, sir.
Yes,
Sir, 117 answer is B, sir.
Yes, yes. So I'm explaining 117 now. It is exosmosis, plasmolysis, then temporary wilting, and if water absorption is stopped completely, it becomes permanent wilting. Okay. So it turns to permanent wilting. So option B is correct. That is exact sequence. Now 118.
Option D is correct.
D.
In 118.
Option D.
Yes, sir. D.
Okay,
Yes,
which
sir,
is
D.
correct. So this is the relation, no? Yes. Option D. Water potential is equal to solid potential plus pressure potential plus metric potential, and metric potential is negligible. Okay, insignificant. So generally we don't take, but if it is in the option, then okay, it is correct. So only the D option. Okay. 119, 120, 120.
Yes, sir. 120.
When a cell is fully turgid, it means what? Which of the following will be zero? Fully turgid. Fully turgid means it is fully turgid means what? It means completely
Suction
tensioned,
pressure will be
more
zero.
water. So turgor pressure is high, na? Turgor pressure is high at that time.
Yeah, turgor pressure is high. If it's a place itself,
And it
then
is
it
equal
will
to
be.
wall pressure. It is equal to wall pressure. So wall pressure is also more. A turgor pressure is equal to in a turgid cell.
Answer is D, sir.
I explained that one. TP is equal to OP. Okay, so DPD is equal to 0. This is the question. This is the question coming from that that equation. DPD is equal to OP minus TP. So if turgor pressure is high, osmotic pressure, it becomes high. Okay, if turgor pressure is high, it means wall pressure is also high. So A, B, and C, all options are more, means turgor pressure, osmotic pressure, wall pressure, they are high. So which is 0? DPD is equal to 0. DPD means suction pressure, SP. It becomes 0 means, it means what? It means now the cell is not able to absorb more water. Okay. So D option. Okay, 121, 22, 23.
121.
123, which is
Same question repeated.
Where? 121, 123.
Yeah, yes, sir. 120.
But it is DPD, that's accepted.
123, almost similar questions.
Yes, yes. Only the
yes, sir. It is repeated in.
correct. But in other way. Okay.
So
Not directly,
121.
but which is 0 in target cell. Yes, so it is DPD again. 123. 121. Entry of water from the soil up to xylem vessels due to entry of water from the soil up to xylem vessels. It is
I
because
think
of
suction pressure, sir. I
it is
think
yes, it is DPD because of DPD. DPD is changed, right? DPD
Gradient
is
of
different.
suction pressure.
Suction pressure, yes. So it is C.
Suction pressure or DPD.
Yes, because of the difference in DPD, water moves. 123, 124, 25.
125.
Sir, 125, sir.
125.
Yes, sir. 125.
Plants die when over fertilized because the fertilizer. Oh, I explained that one also in class. If
Sir, this is
you are
IPVC
adding
question,
fertilizer
sir.
in the soil, if you are adding some salt or fertilizers in the soil, okay, at that time concentration of the soil is more. It becomes more. Mean it is more. It is hypertonic solution. So water moves out. Because of this, plant die. Generally, the plant they absorb water by active transportation. Active transport occurs by using energy. It absorbs more water. It absorbs water from the hypertonic solution to hypotonic solution. But ultimately, if the concentration is not decreased in the soil, so ultimately it will die. 125C, cause dehydration plant by exosmosis. What is the problem? Exosmosis occurs now. Over fertilized soil means what? The solution becomes hypertonic. Okay, it means plasmolysis occurs from the cell, from the root hair, from the epidermal cell, or from the root directly. The water moves outside. Okay, that is exosmosis. Okay, 126.
Sir, 129. 126 and 129.
129.
126. The net direction and rate of osmosis depends upon
B.
the
Sir,
net rate and rate of osmosis.
Pressure gradient and
Option B,
concentration
sir.
gradient.
Option B.
Only concentration gradient, both the pressure gradient, both pressure gradient and concentration
gradient.
gradient. Osmosis depends upon these two, na? Concentration gradient plus pressure also. If you're
Yes,
increasing pressure in the concentrated solution, it starts reverse osmosis. Okay, so I explained this point also. So it depends on two components: pressure gradient plus concentration gradient.
Concentration gradient.
Okay, 127, 28,
129.
29, 129.
So
129, water will move from its region.
So 28
Water
as well.
moves from its region. So what is the issue?
Option D.
Water moves from dilute solution to concentrated solution. It means the pure water, it has maximum water potential. So high water potential, so low water potential.
So 128.
129D option, high water potential, so low water potential, or high free energy to low free energy. Is it clear? 129.
Yes, sir.
Yes, sir.
Okay, 128. Following statement is correct for absorption of water from root air. Statement is correct. Okay, for absorption of water from root air.
Option B, sir.
Option B, sir.
B, sir.
Concentration of outer environment is more than cell sap. So if concentration of outer environment is more than cell, water moves out. And he is asking about absorption of water. So concentration of cell sap is more than outer environment. It is correct. Third is concentration of outer environment equal. It is wrong. Concentration of outer environment is less than. It is wrong. So concentration of cell sap is more than that environment, outer environment. Okay. B option. 130.
130, sir.
130. 130. A plasmolized cell will be water potential. In a plasmolized cell means concentrated solution. Okay, concentrated solution, it means less water potential.
A, sir.
Less water potential, it means solution concentration is more. Pressure potential is also negative. No? If it is plasmolized, then that wall, okay, and the solute and the cellular components, they do not produce pressure, or less pressure is there, and pressure is generally positive. But in a concentrated solution, it is less. In
Sir,
a
which
plasmolized cell, I think it is D option. Okay, it is D. The value of solute potential, it is negative always. A option, it is a normal condition, normal turgid cell is there. Okay, solute potential is there. Normal turgid cell means not only the water but it's solution. Okay, in this A option. B and C not required. Okay, is negligible. Only D option or A option. So A option, this is a normal condition, but the cell is plasmolized. This means it means higher concentrated solution. Okay. So
Sir,
here
in QCAT it is
the
given D.
it is given B.
D, sir.
Not D. Yes, D is possible. Less potential is developed. What pressure potential and solid potential, it becomes more powerful. Okay, more negative because water is completely lost by the cell. So D is possible here. Okay. 131, 131, 132, 133, 34, 35, 36.
As metric potential is negligible, we doesn't consider it, right?
Metric potential is almost negligible.
137, sir.
So it is not considered in the equation.
Sir, but
137.
in one question it was been considered and been given.
No, I
formulated.
didn't. This is the ideal condition. Means in equation generally we use that term, but
Okay.
practically it is negligible.
Okay.
Okay, metric potential.
Sir, 137.
133, sir.
Sir, that's zoology, I think, sir. No.
134.
137. Okay, 137 is zoology.
Zoology, sir.
Two
Sir,
elements needed for
133.
building healthy teeth and bone. Okay, okay. So this is calcium and phosphorus. Okay, see option.
Calcium and phosphorus, sir.
Yes, 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 yes.
133, sir. 133.
Okay, 133. Path of water movement from soil to xylem.
Option
Soil
C.
से start करेंगे तो
Option
soil.
C, sir.
Root
C
है
option.
C, sir.
only option C because it starts with soil. So only this option. Soil, root hair, it enters into cortex, then endodermis, pericycle, and
Endodermis,
xylem.
pericycle,
Then
protoxylem, and
xylem. So xylem means protoxylem, then metaxylem. Protoxylem means immature cells, developing cells of xylem. Then developed cell, these are they have large lumen. So metaxylem. So proto then meta. Okay, so C option only. Okay, 134
Sir, 136.
and 135.
136 is zoology.
136, it is zoology. Yes. My limit is up to 135 only. Okay.
Excuse me, sir.
Yes.
Sir, can you show 116th question?
116.
Yes, sir. Sir, actually it's answer C only, sir. Water potential is equal to solute potential because in NCERT page number 179, it is clearly given that for a solution at atmospheric pressure, water potential is equal to solute potential.
Doubtful thought actually.
Pure water.
I noted that one.
I also was.
Sir, NCERT के लाइनों में लिखा है, sir.
And sir, the same answer
So
is
in
given for
answer
C
key, it
as
is given
well.
C or A?
C, sir. C.
C.
Sir, answer C, yes, sir.
So it is direct from NCERT. Yeah?
Yes, sir, it's direct from NCERT.
Yes, yes, yes. So I think there is no need to check this one, 116.
Okay, sir, but how, sir?
Fine. Only 108.
Sir, can you explain?
108.
Once can you explain 113 again?
113.
Sir, 113, can you explain, sir?
Sir,
Yes.
please.
What 113 says A and B two cells are there. A cell has osmotic pressure 10, turgor pressure 7. So their dPd is equal to 3. Actually, the equation is dPd is equal to OP minus TP. Okay. So OP 10, TP 7. So 10 minus 7. So DPD will come 3. It will be 3. Okay. Now cell B, it has OP 8, TP 3. It means its DPD will be 5. Is it clear? Already they have means here in this question it is given DPD is 3, DPD is 5. So A cell has DPD 3, B cell has DPD 5. And we know that if DPD is higher, it means its thirst is more. It is more hungry than other. If the DPD is high, it means its suction pressure is high. Its power of absorption is high. It is more. Okay, to absorb water. So which has more DPD, which is more hungry, which is more thirsty? DPD is 5. That is hungry. No? This cell is more hungry than the A cell. So water moves from A to B, not B to A. Okay. Is it clear?
Yes, sir.
Yes, sir.
Yes.
Sir.
So
Yes, sir, it's clear,
is
sir.
more hungry than the A cell. B cell is more hungry than A. So obviously it will eat more now. If two persons are there, one A, another is B, suppose. So if B is more hungry, it means it has more capacity to eat. Is it clear? वो एक जो है वो 2 चपाती खाता है, दूसरा 5 चपाती खाता है, 5 चपाती. तो 5 चपाती जो ज्यादा खाएगा वो ज्यादा absorb करेगा ना. It means
Yes,
वो ज्यादा
sir.
powerful. That's it. Okay. This is the question paper. Fine. Now transport in plant. Osmosis, exoosmosis, endoosmosis, turgor pressure, wall pressure, diffusion. Diffusion pressure deficit, DPD is equal to OP minus TP. And also we solve this this problem. OP is suppose DPD is equal to 2 and DPD is equal to 1. So water moves from 1 to 2. Okay. So from B to A in this case. Reverse osmosis, when pressure increases from the concentrated solution, the water moves in the dilute solution. Okay, water potential from high free energy to low free energy, from high potential to low potential, the water moves. This is the relation. Plasmolysis, because of exoosmosis, limiting, incipient, evident plasmolysis. Deplasmosis means reverse of plasmolysis. Absorption of water. These are different types of water. Only capillary water is available. This is the root system for a water absorption. There are two different pathways. Symplast, apoplast. Symplast means through the protoplasm only or living material. Apoplast means through the cell wall or non-living material. You can add that one also, the intercellular space. Mechanism of water potential. This is active water potential. Active water potential, it is of two types. Osmotic condition is there, so no requirement of ATP. Only because of osmosis, water moves inside the cell from the soil, and here the cell wall acts as permeable membrane. Non-osmotic water potential, water absorption, it means when soil concentration is high. When soil concentration is from
absorption.
Water absorption. This is mechanism of water absorption.
Scroll down, sir.
Yes, sir.
Done. Okay. This is osmotic water potential, water absorption.
Yes, sir.
Okay. Then another definition is non-osmotic active absorption. Non-osmotic. And
Yes,
then
sir.
passive water absorption. So in passive water absorption, what happens actually? Water moves, means this is actually translocation of water. Translocation. So in this translocation, passively absorption occurs because of transpiration. The main factor is transpiration here. So transpiration occurs so passively because of transpiration, pull is developed. So here no ATP is required. Directly the water moves from root to leaf. Okay, the farthest point.
Translocation?
Translocation means longer transportation. Okay, long distance transportation. Fine, that is called translocation. If cell means two adjacent cells, if they transfer the material, that is called transport. Short distance, okay, short distance. Long distance transportation, that is translocation. Okay, fine. So next point after this transportation means this absorption of water is imbibition. Imbibition. Okay.
So what
One
is
term we
chemical
use
potential?
imbibition. Any idea? Huh?
Chemical potential.
Chemical potential means that chemical material like hormones, enzymes. Okay, if they produce that pressure, that is chemical potential. But it is actually it is included in solid potential mostly.
Okay, sir.
Okay, what is imbibition?
Absorption of water by an solvent, sir. By a
Okay,
Sir, one scroll up, sir, please.
by
absorptant.
Sir, one scroll up, sir.
this is passive water absorption.
Yes.
Okay, imbibition is actually this is a physical process. This is a physical.
The volume of an object.
Here actually,
Imbibition is absorption of water by the dead cells of plant.
yes, you can say. So this is a hydrophilic substance. Any hydrophilic substance is there, and if it absorb water, but here not absorption, that is adsorption. Okay, the attachment of water molecules on the surface of that substance. Okay, suppose cell wall is there, that is also dead material. Okay, so suppose on cell wall, if the water molecules are attached, that is called imbibition. Okay, that is imbibition. And this imbibition, after imbibition, ultimately the water is absorbed, water enters the cell. This is another thing, but starting phenomena is imbibition. Okay, at primary level, adsorption occurs. Adsorption, it means just attachment of that water molecule or the other molecules, whatever the material. So here, if we use this water and the hydrophilic substance like cell wall or wooden piece, okay, or gum. So here, first of all, adsorption occurs. This is the wooden piece. Suppose, okay. So water molecules. First of all, the water molecules they come in contact with the cell or the wooden piece, and here they are just attached on the surface. They are not directly they do not enter the cell directly. Okay, first of all, this attachment occurs, and that is called adsorption. It is not absorption, it is ad. Okay, D for Delhi. So this is adsorption, not absorption. And then water molecules enter the cell and absorption starts, and because of adsorption, because of this adsorption, finally the volume increases. Volume of this wooden piece increases, or the gum is there. Suppose the gum material is given, then the or seeds. Yes, in seeds actually germination occurs. So before germination, the first phenomenon is adsorption. Okay, first of all, adsorption occurs, then osmosis starts, and then water enters the cell. So that is adsorption process. Okay, during rainy season, you can see this phenomenon. Okay, the wooden door, they swell up because of adsorption. Okay, so this is the process.
So why it is termed
If you
differently like absorption, not absorption?
hello.
What was the reason for terming it as adsorption, not absorption?
Adsorption generally occurs on the hard substance. Okay, means suppose animal cell is there. So here in the animal cell, no adsorption or imbibition occurs. Imbibition generally occurs if the material is dead and hard material is there. Suppose, okay. So on the hard material, directly absorption doesn't occur. First of all, this is the attachment only, and then entry. Okay. So suppose the cell is plant cell or the any material like wooden piece. Mostly we use wooden piece. Okay. So in this case, water is not directly absorbed through the cell wall or cell membrane. First of all, this is the attachment. This is the contact between two. Okay, imbibe and imbibent. Fine. So this attachment, this contact, it is called. This is adsorption actually. It is called adsorption, and this phenomena, that is called imbibition. Okay. In general, if the cell membrane is there only, so directly it absorbs the water. Okay, water or the solution, whatever the present here. So that is absorption. This is absorption. But here in this case, first of all, in these cases, this hydrophilic substance is there. Suppose cell wall is there, or wooden piece is there, or gum is there, or maybe rubber. Okay, rubber is there, so rubber cannot absorb or dissolve water, but it can absorb ether. Okay, the chemical. So it can absorb ether or alcohol also. Fine. That is also adsorption. So here adsorption occurs, then absorption, and because of this, volume of rubber increases. Similarly, in case of wooden piece and water, after some times, this wooden piece volume, it is increased. Okay, and this process is because of imbibition only. Fine. So imbibition means what? Adsorption of water molecules on the on the surface of hydrophilic substances. Hydrophilic substances. Okay, like cell wall. And the example is simple example: wooden piece plus water. Okay, so by adsorption, water is absorbed by wooden piece or wooden door and they swell up. Okay, generally it occurs in rainy season because moisture is there in the air. Okay, so this moisture, the moisture or the water vapors, they are attached to the door or wooden door, and then it is absorbed. So we can see this one, or at the time of germination also. Germination, actually in the germination process, this is seed, and in this seed has this micropyle part. This is micropyle, or suppose this is micropyle. Just a minute. This is a seed and it has one scar. That scar is called micropyle. Okay, micropyle, it is for gaseous exchange and entry of water in the into the embryo, or you can say into the seed. Okay, at the time of germination. Fine. So this is actually adsorption first, and then absorption occurs. So final game is actually absorption, but it starts from adsorption. This is the difference. Okay, so I'll give this definition here: adsorption, absorption. Imbibition is a physical process. First, second, the water molecules come in contact with the hydrophilic substances without forming a solution. Without forming a solution, water are attached or they come in contact with that hard substance, hydrophilic substance. Okay. Absorption of water on the surface of hydrophilic substance is called imbibition. It is called imbibition. Okay. So this is imbibition. For example, at the time of germination, or first of all, that wouldn't work. Okay. For example, wooden door swell up in rainy season due
Sir, I have one doubt, sir.
to
If you keep a raisin inside water and leave it for like 2 or 3 days, it suddenly becomes, suddenly water is inside. So is that imbibition or is that osmosis?
if the wooden piece is taken,
No, if a dried
the
grape,
same experiment is there. Huh?
if you take a dried
No,
grape,
if
sir, and you put it in water, suddenly
no,
all
that is
the
osmosis. That is
that's
osmosis.
osmosis.
That is osmosis. That is osmosis.
Okay,
This
sir.
is osmosis. But here, in this case, because there are you are using different solutions. Okay. But here, the material is completely dead. Okay. Wooden piece
Oh,
is there,
okay.
suppose, or cell wall is there only. That is the difference.
Thank you, sir.
Okay. So swell up in the rainy season due to absorption. Adsorption. That is imbibition. Swells up due to in rainy season due to adsorption of water on their surface. Similarly, if the seeds are pressed in water, they swell up due to imbibition. This is the definition. Adsorption of water on the surface. Okay, this is imbibition. It is not absorption directly, or it is not osmosis. So imbibition occurs. Swelling occurs at that time.
Sir, once can you scroll down?
Here, the wooden piece or on which the surface on which adsorption occurs, imbibition occurs, that is called imbibent. It is imbibent, and that material which is means that suppose the water is there or ether or alcohol, they are called imbibe. Okay, so in this example here, the two terms we use, one is imbibant, and the solution which is absorbed, that is imbibe.
Sir, how do we differentiate between osmosis and imbibition?
In osmosis, there are two solutions, no? Two different solutions through the semi-permeable membrane.
So the water
And
is not
in
absorbed by the
imbibition,
cell, it is only on the surface, right?
yes, surface, yes.
Sir, then
It
how it
doesn't
will,
enter the cell,
how it will swell
enters
up?
And
the
then we
solution.
absorb, no, sir.
Sir,
Then,
if it,
no, see, first of all, adsorption occurs, that is imbibition. Up to that, surface only. When it enters, it is absorption. So this is the phenomena of absorption, water absorption. First of all, the molecules that are attached to the membrane, attached to that cell wall, whatever the point, whatever the surface. So this is adsorption, and finally, ultimately, it is absorbed by the cell. Okay, so there are two different things. It is not directly enter the cell. First of all, it is adsorbed, then absorbed.
yes.
Okay, 2 points are there. Yes, that is, so this phenomena outside the cell, that is called imbibition. Inside the cell means it is osmosis. It is means outer solution is hypotonic, inner solution is hypertonic. So water moves through the membrane inside the cell. That is osmosis. But before this osmosis, before this process, if the cell wall is available, is the dead material is available, at that time it is adsorbed first. Okay, then absorption starts. So the wooden piece, the wooden material on which adsorption or imbibition, you can say, imbibition takes place is called imbibent. And that material or just water molecules which is adsorbed is called imbibe. Okay, so it is imbibe. So imbibent, imbibe. Okay, one more thing. Here, the water molecules, when they are adsorbed on the surface, they lose their kinetic energy. Okay, now they are means in resting position. Not exactly this is the term, but roughly I say that they lose their energy, kinetic energy. Okay, as heat. Fine. So that is called liberation of heat. Here the heat is liberated. Yes, that is called heat of wetting. Okay, heat of wetting occurs here. Just a minute. The water molecules adsorbed on the surface of imbibant lose lose their kinetic energy.
Heat of wetting means this one also.
Sir, can you show from
heat of
first
wetting. Just a minute. So this heat is heat of imbibition, you can say, or heat of wetting. Imbibition heat, roughly, generally we use this term, imbibition heat. Okay, heat of wetting, heat of imbibition. So on imbibent, if they are adsorbed, they lose their kinetic energy as heat. Okay, it is called heat of wetting or imbibition. Heat of wetting, heat of imbibition.
Sir, I have a doubt, sir. Sir?
Yes.
Yes. So the water molecules come in contact with the hydrophilic substances, right, sir? So the hydrophilic substances dissolve with water, no, sir. Then the solution will form automatically.
Hydrophilic substance means no. See, hydrophilic substance means they have affinity with the water molecules. If you are suppose in this experiment we add wooden piece plus ether. Okay, so ether has no affinity with wooden piece. It is hydrophobic. Okay, this is just like
Yes.
lipid and water. So lipid is not hydrophilic, no. It is not dissolved in water. So there is no affinity between two. So here wooden piece, it is hydrophilic means what? It can attract the water molecules. The water molecules, they have affinity with that wooden piece. This is hydrophilic. Okay, means they can attach on the wooden piece easily. If we are using rubber and water, there is no connection, there is no relationship because rubber is completely hydrophobic. Okay, so it cannot absorb the water.
So it takes some time to absorb, sir, for the wooden piece.
It takes time, no? Not immediately. Okay. First of all,
Sir, can you show from
starts
first,
in
sir?
osmosis. Okay.
Which class can you
Let me
show from
finish this
first?
one. Shishir? Yes.
Sir,
One
they
more
must
point.
have a colloidal substance, right?
Huh?
A colloidal substance.
Yes, colloidal like substance. Yes. You can say this. From imbibition.
Yes, sir. For
Hello, sir. Can you show? Thank you.
This is the starting, imbibition.
Slow down, please.
Your voice is not clear.
Sir, can you scroll
So
down,
can you
please,
share
sir?
these slides in the group?
Hello.
Sir, can you share these
Hello?
slides in the group?
No. I'm not going to share anything. Okay. PDF or the notes and all that. Actually, there is a means a strict instruction.
Sir,
If I could,
scroll down, sir.
we should not share anything in the group.
So what
Yes,
did
it
you
is
meant by
completed.
colloidal solution?
Hello. Colloidal suspension. This is suspension actually. Colloidal means what? Suspension, not completely dissolved. Okay. Some materials they move continuously in that environment. Like protoplasm is also colloidal solution. It is not just a solution. Not all things are dissolved. All materials are dissolved. So protein, lipids. Okay. This is a mixture actually. A colloidal solution like structure. This is actually chemistry term. Colloidal solution, it means what? Not complete. Just suppose the salt solution or sugar solution. It is not colloidal. No, sugar is completely dissolved in water, so it is solution, pure solution. Colloidal solution, it means if you are adding some lipid or fat or oil, okay, it is not dissolved. It is suspended only. So this is called colloidal solution. Fine. So numerous different materials, enzymes, hormones, other molecules, they are dissolved in a protoplasm, but they are not completely dissolved. They are just in colloidal state. That is colloidal solution. Is it
Sir, what
completed?
is the kinetic energy formula?
Huh? No, I have no idea. I have no idea this one. This is physics. This is chemistry. Okay. So I have no idea about this. Is it
So the
completed?
water is colliding with the colloidal surface, so adsorption is happening.
The surface is colloidal, means it form first of all, the thing is that solution is not formed. Okay, means there is no dissolution. Dissolution means what? You are adding solute and the water, here the solution is formed, it is completely dissolved. In this case, on the water, means the water molecules, they are not entering the solution. Okay, so this is only just attachment on the surface, the wooden surface. So it acts as means suspension, like you can say, that is colloidal, but not
Sir,
exactly
shall we
colloidal.
do
It's called
sheets and
suspension.
DPPs?
It is called, hello.
Sir, shall we do sheets and DPPs?
Yes, a DPP. I think it is DPP first, maybe in a transport, because I have no DPP actually. So see that one, the transport in plant is given in which DPP? DPP first or second? So complete that DPP.
Thank you, sir.
And after completion of the chapter, the exercise 1, 2, 3 given after this chapter in the sheet. So complete these questions also, okay? Because most of the time they make the questions from the sheets, okay, at primary level, but after that they will give you some difficult question also. Okay, this is practice actually. Is it completed?
Yes, sir. Sir, can you read this last point, sir? It is called heat of wetting, or is it or?
Imbibition. Wetting or imbibition. Heat of wetting, heat of imbibition. Yes, one more point is here. Imbibition pressure. Actually, this imbibition, it creates one pressure because of this adsorption of water on the surface. So it produces, it is produced by these imbibent also. Okay. And it is called imbibition pressure. Even this magnitude of this pressure, it is very high. Okay, it can break the wooden piece. It can break the rock also. If you place this wooden piece between the rock, suppose these are two different portions of rocks. Okay, just a minute, just if it is a wooden piece is fixed, it is placed between two rocks. Just a minute. This is a wooden piece. Okay, so it is placed between two rocks. The crevices between two rocks, suppose, and the adsorption occurs, imbibition occurs. Okay, so the imbibent, the wooden piece, it creates a pressure after this adsorption of water, and it is sufficient to break the this rock. Okay, this is imbibition pressure. Can you hear me?
Yes, sir.
Yes, sir.
Okay, so this is the pressure, means its magnitude is very high of this this imbibition pressure, and it can break the rock. Okay, not completely, it is not blasting, but yes, it can form a crack in the rock. Okay, this is the pressure. Just a minute.
So can you repeat? I didn't understand.
Okay, Just a minute, just a minute. In imbibition, during imbibition occurs means what? It means adsorption of water on the imbibant. The imbibant is wooden piece. Okay, wooden piece is placed between two rocks or the crevices of the rock. It creates a pressure that is called imbibition pressure, and the magnitude of this pressure is very high. It can break the rock. It can form the crack in the rock. Okay, so similar example is there. Suppose if you are using one bottle, glass bottle, and in the glass bottle, if it is almost is filled with the seeds, these are seeds. Okay,
Sir, we had
not
the
water.
similar question in our sheet.
Yes, sir. We had the
So
same
this
question in
these
DPP.
are this is small amount of water only. Yes, small amount of water is there. The question will be like one professor is there in the class, something.
Yes, sir, it
In the
was the
starting
same.
of the class, he placed one bottle. Okay, completely filled with the seeds and some amount of water only. The water should be less, here. Otherwise, pressure is not developed. So small amount of water and completely filled with the seeds. What will happen after means, in the question? Maybe they will ask like this: after 1 hour lecture, the bottle will burst or something. There is a blast in bottle. Why? Because of imbibition pressure. Okay, the pressure is developed by this imbibant. Here imbibant is seed, it is not wooden piece. It is seed. It absorb water. Okay, so because of this bottle will burst. Okay, a blast occurs. This is the imbibition pressure. Just a minute. A pressure is produced by
Sir, I have a
imbibant.
doubt, sir.
Someone is asking. Yes, yes.
Repeat, sir.
A pressure is produced by imbibant.
Sir, is
Continue.
imbibant
After
pressure like same to osmosis, sir? Because the seed is getting swelled up here also, and the seed is getting swelled up in the osmosis also. So is this both same?
No, see, in osmosis, what happens? From lower concentration to high concentration, water moves, okay, through the semi-permeable membrane. Before this osmosis, imbibition occurs. This is the difference. On the surface, adsorption, attachment of water, that is called imbibition, and the water molecules enter the cell, that is osmosis. This is endoosmosis. Clear? So this is water molecule. This is also water molecule. So generally we say this is a osmosis through the semi-permeable membrane. Yes, it is correct. But before this, just before this, adsorption occurs, attachment of water molecules on the surface. This is adsorption or imbibition.
Okay,
Is
so
it
thank
clear?
you.
Okay, pressure is produced by imbibant after complete absorption or adsorption. Generally, you will see in the book absorption. It is also correct here. Absorption means after completion. No, after completion. So after completion of imbibition, definitely absorption occurs. But here I use word adsorption. So complete adsorption. A pressure is produced by imbibant after complete adsorption or absorption is called imbibition pressure. It is imbibition pressure. Okay. IP, that is called IP. So imbibition pressure is there. Its magnitude, the magnitude of IP, imbibition pressure is very high. It is very high. Okay. For example, if a wooden piece is placed or fixed between the rocks, between two rocks or the crevices of the rock, okay, is placed into rock, occurs it can it creates a crack in the rock. Okay, this is imbibition pressure. So liberation of heat, heat of imbibition, and imbibition pressure. Fine. Here, the imbibition capacity is also given. Okay, capacity may, I think the most powerful imbibant is agar agar. Okay, this is agar agar. It is also polysaccharide, huh? So agar agar, then
Sir, can you show the upper point, sir?
the
Sir,
pressure is
okay,
produced
upper.
from imbibant. Before this one
Ambient pressure, sir. IP.
is IP. Yes,
Sir,
a
done.
pressure is produced by this one. Okay. Now, imbibition pressure, imbibition capacity, that is called suction capacity. No? So imbibition capacity it is highest in agar agar. So there is a sequence, sequentially you can write agar agar, then protein. Protein or starch?
Sir,
Let me remember. Agar agar,
Starch.
then pectin, then starch, then cellulose. This is the sequence. PSC.
Sir, the wooden piece placed in a rock means the water from wooden piece absorbed by the rock and cracks develop.
No, it is not absorbed by rock. It is absorbed by that piece, wooden piece. This is rock, no? So rock doesn't absorb water. If there is no humus, only stone is there. This is rock.
Yes, sir.
Okay. The wooden piece absorbs water, no? The wooden is there. If the crevice is there or any gap is there and you are fixing this rock, this wooden piece in the rock. Okay, if you are inserting this wooden piece in the rock. So because of rainy season, or suppose you just use this water here in this on this wood, so wooden piece here, adsorption starts, imbibition starts, and because of this a pressure is created by this wooden piece, not by rock, huh? The pressure is created by the imbibant only, na? It is absorbing water. It is showing, it is performing imbibition. So imbibant shows that pressure, it creates that pressure which can crack the rock. Okay.
Yes.
Imbibition capacity It is mostly just. It is maximum in agar agar. Then
Sir, that jelly substance.
agar agar to that is jelly substance, jelly like material. Yes, good. It is used in jelly industry. Okay, jelly beer industry as a clearing agent, cosmetics, paste. So agar agar uses use as a
Agar agar is a
fixer.
algae.
Means algae material. It is not
Dead
algae, but
algae.
algae produces, yes, algae
Like
production.
gelatin.
Gelatin like, yes, jelly like material. Okay, agar agar. It is used in nutrient medium in tissue culture also. Okay, and it is obtained from algae, red algae. Okay, so agar agar, then protein. Less than protein, it is pectin. It is also polysaccharide. Then our starch. This is polysaccharide, and then another type of polysaccharide is cellulose. Okay, so agar agar has maximum capacity to show imbibition. Okay, so imbibition occurs during germination also. Okay, seed germination, at the time of seed germination it occurs, shown by seed code. Okay, this is imbibition. Okay, now the next point.
Once can you scroll up, please?
The next topic is actually transpiration. Okay, transpiration. What is transpiration?
Loss of water and vapor.
Loss of water
Loss
from
of water
leaf.
by leaves, sir.
Loss of water by
Loss of
leaf.
water
Where?
in form of water vapor by the
In
aerial plant.
vapors. Yes,
Aerial part.
yes, in the form of vapors through the aerial part. That is called transpiration. It is
Submerge.
loss of water from the aerial part of the plant. Loss of water as vapors, as water vapors. So in the form of vapors, water loss from the aerial part, especially leaves. That is transpiration. Okay. Yes. Next is transpiration. So first of all, definition. Transpiration is the loss of water
Excuse me, sir. Can you once please scroll up?
in the form of vapors. Here, imbibition capacity.
Yes, sir. Thank you.
Form of vapor. Transpiration is the loss of water in the form of vapors from the aerial parts of the plant. That is transpiration. Okay. Rate of transpiration is measured by means transpiration rate is lower or maximum or higher. Rate of transpiration is measured by photometer. Okay, photometer. So through the photometer, we can measure this rate of transpiration. Fine. Now, different types of transpiration. So maximum transpiration occurs through the stomata. Stomata are present on the leaves. Okay, as you know. So maximum transpiration, most of the time transpiration occurs through the stomata which are present on the leaves. So different types of transpiration. First, it is stomatal. Stomatal transpiration. Stomatal transpiration means around 95-96% of total transpiration occurs through the stomata most of the time. Okay. But yes,
scroll up, sir.
it is possible from 90 to 97 because through the cuticle, it has been observed that in some plants through the cuticle even transpiration occurs. Okay. Generally, cuticle is the waxy layer.
Cuticle.
No, not cuticell. That is lenticell. Okay, lenticell is different. I'm coming to the point. Lenticell is different. Cuticle. So cuticle is a waxy layer generally present on the plant, especially on the leaves. Okay, but sometimes transpiration also occurs. Some amount of transpiration, around 5 to 10%. It is possible through the cuticle. Even they are means they are here to protect the leaf to avoid transpiration. But transpiration is possible through the cuticle. So first of all, transpiration by stomatal transpiration. They are present on the leaves. Stomata are present on leaves. It is about 90 to 97%. 90 to 97% of total transpiration.
Sir, can you scroll?
From starting transpiration. Done?
Yes.
Okay. So 97%. This is stomatal. Okay. Next, it is cuticular. Cuticular transpiration. Cuticular transpiration through the cuticle. About 5 to 10%. Can you hear me?
Yes, sir, you're audible.
Yes, sir, you're audible.
Oh, okay. About
Yes,
5
sir,
to 10% transpiration occurs through cuticle.
Sir, where is this cuticle present?
Hello?
The location of this cuticle, sir, in the plant.
On the leaf surface. Generally,
On
this
the
is
leaf
leaf
itself.
surface, suppose leaf. And in herbaceous plant, even the green stem, they have this cuticle. To avoid transpiration, actually, this is waxy layer. Cuticle is waxy layer.
Your
Okay.
voice is glitching,
To
sir.
avoid transpiration. Of transpiration occurs through the cuticle.
Sir, your voice is not clear, sir. It's breaking.
Now is it okay? Just now am I audible?
It is clear to us, sir.
Am I audible?
Yes, sir.
Yes, sir.
Yes, sir, it is audible to us.
Fine. So this is cuticle, a waxy layer to protect the leaf from the transpiration. Okay. It prevents transpiration actually. It's responsibility to prevent loss of water. But sometimes here also some vapors, it is possible to lose out. Okay. The vapors in the vapor form, always vapor form. Even it is
Sir, it is a wax.
critical transpiration, either wax layer. Yes, waxy material is there actually on the leaves. Okay. Suppose, okay, for example,
Sir, we do find this cuticle on a fingers.
you have
leaf
seen that that
and
leaf of lotus.
Yes, sir.
Yes, sir.
Yes, sir, we can observe.
Are you aware
Yes,
of
sir.
this? Yes, that is very easy, no? So leaf of lotus, it has that cuticle, so it cannot absorb that water. Water point means that water drop. It is just attached on that leaf. Okay, but it cannot be absorbed by the leaf. Okay, so that is because of this waxy layer on the plants. Mostly it is present in the hydrophytic plants, aquatic plants. Okay.
Then will
To avoid
respiration occur, sir?
that harmful effect of water on the cell.
So then will respiration occur for them in those plants whose this is blocked?
If cuticle is present,
Yes, sir.
there is no issue. There is no issue, no, because here the gap is there. That is stomata. So stomata is always present here.
Sir, does colicacia have
Just I'm showing you.
cuticles on
This
them?
is this one.
Does colicacia have cuticles on them?
Colocasia.
Yes, sir.
No. Colocasia. This is general mesophytic cell. Colocasia. I think yes. Colocasia. They have that cuticle. Yes, they have the cuticle. Colocasia, lotus. Many plants they have this type of structure. Even they are mesophytic. But it is common in hydrophytic plants. Trapa,
Can you scroll down once?
Wolfia. Okay. Or someone is asking about respiration. So this is respiration because we have this arrangement now. These are the guard cells. They form stomata. But this opening, it's called stomata, and because of this, the air enters the cell. Okay. So here cuticle is absent. Fine. Cuticle is present only on the epidermis. No? If epidermis is absent, automatically the cuticle is absent. So gaseous exchange is okay. Gaseous exchange occurs through this stomata only. So the point is cuticle absorption, transpiration here. 5 to 10% total transpiration occurs through the cuticle. Okay, that is cuticular transpiration. Another transpiration is very less, but yes, it occurs in some plants where the stem, the branches, they are delicate. Mostly it is in herbaceous plants or in woody plant also. So in woody plant, you can see small gaps are there in the bark. Okay. And this gap is actually, it is called lenticel. This is not stomata. This is called lenticel. Around.
Sir, lenticels are used for respiration.
They are for gaseous exchange also. They are for gaseous exchange. So next is lenticular. lenticular transpiration. What is lenticular transpiration? Actually, some amount of water
So once can you scroll imbibition, sir? The water after heat of heating or imbibition, that part.
just a minute, just a minute. Some amount of water is transpired by lenticel present
So some amount of water is transpired or respired?
in the stem. Transpired. It is not respired. TRNS, no? In the stem, and even the fruits, they have that lenticel also. Huh? The fruits. Maybe they ask like this: lenticels are present on stem, fruits, leaves. So stem and fruits both are correct. Okay. About 0.1 to 1% of total transpiration. That is lenticular transpiration. Now, the main transpiration is actually stomatal transpiration. Okay, through the leaves, through the stomata. So, what is stomata? Stomata is just an opening. I'm showing you here. This is structure of stomata.
Can you scroll up, sir, the lenticular transpiration while I
You are asking for stomatal transpiration.
no, sir, lenticular transpiration.
Lenticular.
Sir, can you read the last point in lenticular transpiration?
About 0.1 to 1% of total transpiration. That is lenticular transpiration.
Okay, sir. Thank you.
Okay, done. Stomata. What is stomata? It is an opening or a gap or an aperture produced by two cells. So actually stomata is formed by two different cells. Stomata is an aperture in the epidermis of the leaves.
Sir, how the lenticular transpiration present in stem, sir?
Actually, water is also present in the cortical region. No? So cortex cells are there, complementary cells are there, cork
Sir,
cambium.
can you show the sixth point of imbibition, sir?
So here actually lenticels means what? This is opening, and before this or behind this opening, the cells are present which are living cells. Okay, so they have that water just like guard cells in the stomata. So these cells, they lose their water. From where, Shishir? Imbibition pressure.
Sir, done. I took screenshots, sir.
Okay, fine. So, okay, what was the question? Yes, lenticel. No? Lenticels are here. This is lenticel. We'll see in anatomy. These are the cells. They are called cork cells. These are dead cells. Okay. Here, some cells are present. These are complementary cells. Okay. And the other layers are there. So, because of secondary growth, a pressure is produced by the inner cells towards outside. So these cells, they break the epidermis cork. Okay, and because of this, not cork exactly, this is epidermis, sorry, this is epidermis, and these are cork cells. These are cork cells. Okay, so these cork cells are hard dead material, but some cells of cork, these are living thin parenchyma cells, these cells. Because of this high pressure from the pericycle and other cells, this pressure, it breaks this epidermis, this part of epidermis. It is broken down. Okay, so the opening is developed, and this opening is called lenticel. So this lenticel, from here, these cells, these are living cells now. So these cells, they have water. The water is coming out in the form of vapors.
Sir, can you repeat, sir?
Oh, actually, this is part of anatomy. It is part of anatomy, not in physiology. So I'm just giving that idea only, not in detail. Actually, this is epidermis, as you know. This is the epidermal layer. Okay, epidermis. It is not present in the leaf. It is in the stem where secondary growth occurs. In the leaf, secondary growth absent. So here there are so many different tissues. This is pericycle, phloem, xylem, and all that. Okay. So because of secondary growth, the outer ring, continuous secondary growth occur because the meristem is developed, the meristem is active, and because of this, cells are formed outside and inside of the cambial ring. This is cambial ring. So outside the phloem is developed, and because of this, the pressure is increased towards the periphery. Okay, to avoid or to resist this pressure, a periderm is formed. Periderm is 3 layers actually: cork, cork cambium, and secondary cortex. So this is the cork. This is cork. Inner is cork cambium and innermost is secondary cork. These are 3 layers. Fine, clear. So in the stem, what is the arrangement? The cork cells, they have 2 types of patches. Cork cells. Some cells are the dead cell. So these are dead cells. Diameter cells. Some cells are living cells. They remain living, and they are called complementary cells. These are complementary cells. These spherical rounded cells. So these are living cells. Because of high pressure, this living cells, they are thin-walled parenchymatous. So they pressurize the endodermal, epidermal cells, which are also living cells. So because of this pressure, some living cells, some complementary cells, and the epidermal cells, the breakdown occurs here. Okay, they are broken down because of high pressure, and because of this, one opening is developed. This opening is called lenticel. Okay, these are just opening. There is no mechanism of closing. They are always open. They remain open. Clear? Lenticels, but stomata you can close them because there is a proper mechanism of in the guard cells. Am I clear?
Yes, sir.
Hmm.
Sir, once
So
can you scroll up?
So what's the first point of the matter?
Stomata is an aperture. In aperture means opening, gap, pore. Okay, in the epidermis of the leaves, not in stem. Okay, stem में नहीं होगा. Stem में only lenticels. This is stomata. Stomata is formed by
The one can show lenticular transference.
each lenticular transpiration. This is lenticular transpiration. Each stomata is formed by two kidney shaped,
Thank you, sir.
or you can say bean shaped. Bean shaped is more common. Huh? So kidney shaped or bean shaped cells. These cells.
Sir, they are guard cells.
Yes, guard cells. Yes, these are guard cells.
Excuse me,
These
sir.
kidney shaped
What's the
cells
first
are
one,
called
sir?
guard
Can you
cells.
repeat once?
Which point? Second point.
First one.
First.
First
Stomata
one,
is an
sir.
aperture in the epidermis. Stomata is an aperture in the epidermis of the leaves. Okay. Each stomata is formed by, or it consists of two cells. It is formed by two cells, two kidney shaped or bean shaped cells. They are called guard cells. The guard cells contain both. The guard cells, chloroplast. These are also green.
Sir,
They
after
can perform
kidney,
photosynthesis.
what is that, sir? Or
Hello, I'm not getting you. Your voice is breaking. Who is she? So the guard cell contain, each guard cell, both guard cells, they contain chloroplast. I think time is over.
yes, sir.
It will take time actually. Stomata is not small point. It is not that much. Actually, there are types of stomata. Okay, on the basis of distribution, on the basis of stomatal opening. Okay, fine. So we have to see this one in next class only. Because time is over
What's
here.
this topic for this weekend test, sir?
Complete transport in plant. Complete.
Yes,
Okay.
Sir, only the transport.
We'll have from the beginning, sir.
Only transport in plant.
The 11th chapter total.
Sir, what is the syllabus, sir, for this week exam?
Transport in plant. Complete.
Yeah.
And we'll complete this one. Okay. So don't worry. Transport in
Sir,
plant.
this week the paper will be made by local
That is LPT.
hyperpath resonance,
That is
sir.
LPT. Yes, that is LPT. It is not from quota.
Sir, it is not of 720
Quota
marks.
will take CT1 and no. All things are same. All design is same. Okay, it is 720 marks. Means 45 questions from each. So all pattern is same, completely same structure, but only the questions generally we prepare locally. Okay, according to our class or the explanation. Fine.
So
But
once
CT,
can you scroll
they
up,
come
sir?
from quota only. From which point?
Inspiration, sir.
Transpiration.
Yes, sir. Thank you, sir.
Take the screenshot. Okay. Next. Do you want this one also?
Yes, sir.
Yes. So stomatal transpiration, then cuticular transpiration.
So can we leave?
Sir, can we leave?
Done? Yes.
Yes, sir. Thank you, sir.
Sir, we still
Thank
did
you,
not
sir.
receive
Thank
our
you, sir.
rank.
Thank you, sir.
Thank you. Bye.
Thank you, sir.
Sir, we didn't receive our rank.
Sir.
Thank you, sir.
Thank you.
Thank you, sir.